All right, graphing cosecant and secant. All right, we're going to get right into the problems. Graph number 1, y equals secant x. We're going to graph y equals secant of x. All right, so this is us thinking, y equals secant x. Secant is the reciprocal of which function, cosine or sine? So cosine of x is the function that we think of to graph. We don't even touch this yet. This is what we're going to start with right here. Amplitude 1, period pi over b or 2 pi over b.
Pi over b?
Pi over b only happens for which two functions? Tan and cotan. Secant and cosecant work just like cosine and sine, so what is it? 2 pi over 1, which is 2 pi. Does that make sense? All right, I'm going to make this one a little bigger than usual because we will, as you saw in the graph I showed you earlier, be sketching out a little bit more. Still 1 period length. All right, so I guess this is a bit exaggerated. What is the period length? 2 pi. What's half of 2 pi? What's half of pi? And then 1 over 2, 2 over 2, this is 3 pi over 2, 4 pi over 2, does it work? Also get practice with 1 plus 2 is 3, 3 cut in half is 3 over 2. All right, amp is 1. Okay. Now, I'm just going to do the key points. I'm not going to sketch the whole thing. If you're working with pen, I suggest you change to pencil because we're going to do some erasing. All right. If you don't have a pencil, borrow one from a friend, or don't sketch everything I'm sketching until I tell you to. All right. Secant, cosine. Cosine is the one that starts at the 0 and snakes around, or the one that starts at the maximum and cup shapes. Cup shape, and since it's positive, it starts at the max, 0, minimum, 0, max. Do you guys agree those are the key points? Yes or no? Okay, so this point, if you have a pen, you do not want to draw. I'm going to lightly sketch. We're going to come through later and erase that, but that's why I'm trying to do it light. Okay, do you guys remember when I've talked about hills and valleys? What have I said here? This is a hill, but I haven't called it a hill. I've called it a half a hill, a valley, and half a hill. Do you guys remember that? Half a hill, a valley, and half a hill. Okay, keep that in mind because it's going to reflect in our graph. All right, reciprocal functions. We all agree that secant is a reciprocal of cosine, which means secant equals 1 over cosine. Yes? All right. Now, do you guys remember what the reciprocal of 0 is? Undefined, because 0, you can put 0 over anything. Is 0 over 7, 0?
Yeah.
What's the reciprocal of 7 over 0, which is? Undefined. You could make that a 1 if you wanted. All right, so what is the reciprocal of 0? And when you're graphing and you graph undefined, you make, what are these lines called? Asymptotes. Now these are actual asymptotes. These are not the fake axis or axes that we've been drawing in our other problems. These are actual asymptotes. Okay, what does that mean? The graph is going to get really close, but never touch. Okay, now, what's the reciprocal of 1? So that point's going to stay. What's the reciprocal of negative 1? Negative 1's going to stay. What's the reciprocal of 1? It's going to stay. Everything else, this piece in here is what's going to change. All right. I'm going to come about here. What's the, okay, if this is 1/2, what's the reciprocal of 1/2? 2. So it would be up here. Do you agree? If this is a 1/4, what's the reciprocal of 1/4? 4. You guys see that?
Yeah, you lost me.
Okay.
I don't know why you're doing it, but yeah.
Okay, because, okay, I don't know why you're doing it. Secant is the reciprocal of cosine. So whatever cosine's answers are, secant flips them all. So cosine, is that what we're dealing with? Root 3 over 2 becomes 2 over root 3. 1 over root 2 becomes root 2 over 1. 1/2 becomes 2. So here I'm saying this is approximately a half. If this is 1/2, what's the reciprocal of 1/2? 2.
So
Oh, I
why are
see.
you
I
using
get it.
1/2 though? Because I thought for the cosine graph you have like 0, 1, pi over 2, 0.
Yes.
Pi negative 1.
I'm just randomly picking points just to show you. For example, this is 1/4, 2/4. If this is 3/4, what's the reciprocal of 3/4? Okay, so what's happening to all these dots? They're flipping around like this. And they go on forever with arrows, getting closer and closer to the green line. Okay, now I'm going to continue. Well, what's going to happen here? Same concept. What's half, or what's 1 over 2 flipped?
2.
Okay, so all these things are going up as well. Okay, now, if you don't like the math behind it, the reciprocals and reciprocals, my other class said, oh, is it just flipping? Yes, you see how this is opening down? Then the reciprocal opens up. You see how this is concave down, and then the reciprocal goes up. So this one that has this upward U shape is going to do what?
Go the other way around.
Go the other way around, again with arrows. So it's kind of like a parabola shape. It's not a parabola, but it has that parabola shape, and it's opening downward. Okay, so all of this is gone. So what is your graph? These two half parabola-like shapes and this full parabola-like shape. Okay, now why is there one full and two halves? Do you remember when I said half the hill, the valley, and half the hill? That's why. Listen to it. Half the hill, a valley, half a hill. How many total valleys do I have?
1.
1. And how many half hills do I have? 2. So 2 halves and 1 whole. Do you see that? Does that make sense? Yes.
Would you erase the dots at pi over 2, or would you keep them there? Since it's an asymptote?
It doesn't matter. You can't, I mean, I'm not going to mark it wrong if you left them there.
Okay.
But yes, technically there's no points there. So yeah. Are we good?
I think that was
Mm-hmm. So, what do you think the negative secant is going to do?
these values flip.
Reflective across the x-axis.
What if you reflected it
What if you shifted? That question did come up this morning. What happens if you shift, a vertical shift? The fake zeros work just like your real zeros when you're dealing with shifting. We'll get to one of those eventually. Any questions here? All right, I am going to move up just a smidge. And number 2. Y equals cosecant of x. All right, so this is us thinking, cosecant's the reciprocal of which one? Sine. So sine of x is what we're going to first start off in finding our key points. What is the amplitude? What is the period length? 2 pi. Okay. What's half of 2 pi? What's half of pi? So let's use the other shortcut that we have. 1 plus 2 is 3. Cut in half is 3 pi over 2. All right, amp is 1, -1. Now sine is the one that starts at the max and cup shapes, or starts at 0 and snake shapes? Okay, and it's positive sign, so 0, maximum, 0, minimum, 0. All right, how many zeros did we have on the original cosine graph? Before I'm right here. How many zeros do we have on a cosine graph? 2. Is that always true for cosine graphs in one period? Yes. So, how many zeros do we have on a sine graph? 3. Do you see the 3 zeros here? That means we're going to have how many asymptotes? 3. Does that make sense? Okay, 2 asymptotes here because there were 3 zeros. I'm sorry, 2 zeros. And 3 asymptotes here because there are 3 zeros. Happening at 0, at pi, and at 2 pi. Okay, now when I lightly sketch the sign in here, what would I say in words with like hills and valleys, or half hills and half valleys? What would I say here? A full hill and a full valley. Would I use the word half here at all? No. Hill and a valley. So am I going to have any of these half markings like this? No, it's going to be 2 full ones like this. Now, remember what I said about reflecting or reciprocal functions going the opposite way? So if this one goes downward, which way is my parabola-like shape going to open? Upward. Yes.
So this is probably kind of like a dumb question, but when you have your, like the green dotted lines, those are the asymptotes, right?
Mm-hmm.
So do you use those because that's undefined?
Yes.
Okay.
And
so when you say, for instance, 2 pi is undefined, like when you do the reciprocal, is it just undefined?
I'm glad you said that. Okay, so we're not taking the reciprocal of the x values. We're taking reciprocals of the y values. So cosecant of 2 pi equals, sorry, sine of 2 pi is 0. Do you agree with that? Think of your circle. Here's 2 pi. This is 1, 0. Is sine 0? Okay. So then cosecant of 2 pi is the reciprocal of your answer. So if this is 0 over 1, what's the reciprocal of 0 over 1? Undefined. Okay, so you're not taking the reciprocal of these x values. You're taking the reciprocal of what the answer is. So sine of 2 pi is 0. Cosecant of 2 pi is undefined. Does that make sense? Okay, good. I'm glad you asked. All right, so I erased this in here, the original little bump. Now this one is opening upward, so which way is my parabola-like shape going to open? Downward. Again, are these parabolas? No, they are not. Parabolas get wider and wider with no restrictions. These do get wider, but they're restricted between those asymptotes. All right. Questions?
Don't move that.
I won't. Now, I'm just going to move it down just a smidge, because I did have a kid this morning ask of this. She said, does this piece always need to go this way, or could it be like the other way instead? Could it be this half? Okay, do you see how this bump is going down here to the left, and you should be going up to the left? Does that make sense? Or another way to think about it is your arrows should always, your graph should always be going towards your asymptotes. Do you see how this one's getting closer to the asymptote? This one's getting closer to the asymptote. And what's happening here with these two? Closer to the asymptote. Same thing here. Closer to the asymptotes as you go up, and closer to the asymptotes as you go down. Make sense? Questions? None? All right, number 3. No, I'm not moving it. You're okay. Write it down if you're ready. Y equals -3 cosecant of x I'll repeat that. Y equals -3 cosecant of x. And then not in parentheses, there is a +2. Go ahead and work. Ready? And I apologize for starting without you.
Actually, no. I have that little side note. That's okay.
No, you're okay. Did everybody write it down? -3 cosecant x +2, and the +2 is not in parentheses. So what graph should you be thinking of? Sine. Y equals -3 sine x +2. What is your amp? Period. 2 pi. And vertical shift? Up 2. And is there a horizontal shift? Okay, you guys want to try it on your own? Or do you want me to just show you how to do it? Show, and I will because you weren't here in the beginning. All right. Okay, so I'm going to graph mine like this with a lot of space up at the top because of the shift. All right, 2 pi. What's 2 pi cut in half? And pi cut in half. 1/2, 2/2, this is 3 pi over 2. And, all right, when we had vertical shifts, do you guys remember what was said? Which part do you do first, the amp or the vertical shift? Vertical shift. Put your phones away, please. Vertical shift is 2, so I go up 2. Now, without graphing, ignore the cosecant, just the regular sign. Without graphing, if your vertical shift is 2 and your amp is 3, what is going to be your max and your min for the sine graph? 5 and -1. Megan's not here, but she said last time she just takes this 2 and then she adds and subtracts 3. What's 2 plus 3? And what's 2 minus 3? Does that work? Okay, 2 plus 3, so 1, 2, 3. That's 1, 2, 3, 4, and 5. And then down 1, 2, and 3 puts you at -1. Yes or no? Okay, so vertical shift first, you draw your fake axis. This is not an asymptote. That is a fake axis. And then we adjust our amp. 3. 1, 2, 3 to 5. 1, 2, 3 down to -1. All right, this is negative sign. Does negative sign still start at 0? Or fake 0 in this case? Yes? And then because it's negative, do I go to my max or my min? Min, so I swing down here. Next key point is a fake 0, maximum, and then what? Back to my fake zeros. Okay, now what's nice about this is we use our fake zeros for the asymptotes. Okay, because when you actually plug it in, it does work out to be undefined. Okay, so use your fake zeros as your asymptote. So how many fake zeros do we have? 3. And those 3, here, here, and here, are going to be your asymptotes. Okay, so these dotted lines in green, those are my asymptotes. So 0, pi, and 2 pi. Got it? Okay. Okay, so eventually you will not, oh, before I go any further, can I come back really quick and just explain something? Your graphs always go away from your x-axis or your fake axis. Do you see how this is my x-axis and the graphs up here go upward and down here go downward? Will that always happen? Okay, in this graph, how many zeros do I have?
2.
How many zeros do I have?
2.
None.
None. Do you guys see that?
Yeah.
Okay, when they ask you that question on the test, how many zeros do you have here? What do you say? None. Some kids forget to erase the cosine graph and they're like, oh, there's 2 zeros here. No, that part that we erased is not part of your graph. All right, so same thing here. Your graphs go away from your x-axis. This point up here goes upward. This point down here goes downward. How many zeros do I have? None. Do you guys see that?
So do you never have zeros on these graphs?
Unless there's a vertical shift. Okay, if there's no vertical shift, you will never have zeros. All right, so here, with the vertical shift, we still move away, not from the axis, but away from the fake axis. So this one would go up or down? Down? And this one up here would go up, again, towards your asymptotes. Now, if you don't see that, I'll put the graph in lightly and then erase. There it is there. And do you see, like, this is opening up, it goes the upward direction, this one's going down, going the opposite direction. It never goes towards your axis or your x-axis. Now, did this one shift us enough to give us zeros? Do I have any zeros on this one? No, still no zeros. What kind of change would have to be made? There's a variety of changes you can say. What kind of changes would have to be made in order for us to have a x-intercept?
Would it be like a negative shift down? Or a shift down?
It could be a shift down, or it could still be a shift up. What if this shift up was, yes?
And upward shift.
What if I shifted upward, or if this was positive? Is that what you're saying? If it was positive, yes. Oh, nope, it still wouldn't have. Yes.
If the vertical shift is higher than the amp.
Good job. Okay, so if this vertical shift moved up higher, that means this would move up higher and then would open up here and open down. Does that make sense? All right. Okay, so still here there's no zeros, but either way, I move away from the fake axis. Does that make sense? Yes.
So on a test, like, you wouldn't, like, when you do your asymptotes, you wouldn't, like, you wouldn't permanently do the vertical asymptote. Like, that's just a fake
This one
asymptote.
here?
Yeah, or
Yeah.
would you put that down?
Well,
Or would you, could you dotted line it?
yes. This is not part of your graph at all.
Okay.
So yeah, that's why I do them in different colors anyway. And every time I've done in the past, I like, these are not asymptotes, it's a fake axis. So yeah, keep mind of that. If you left them in your graph, I'd be fine with it. But technically, it's not part of your graph. All right? Okay. Number 4. Y equals negative secant parentheses 2x minus pi, close parentheses. Okay, what are we processing in our head? What kind of graph?
Cosine.
Y equals negative cosine parentheses 2x minus pi. Okay, 2 places kids mess up on the test. When they rethink this, they think, oh, it's negative sine, and the whole thing is wrong. So keep track of secant, cosine, and so forth. The other mistake kids make is up here, like this one here. They do all the key points. They do this graph, and then they stop, and they forget to change it back to the cosecant. So they do the original one that I erased earlier. They get that in there, and they're like, oh, I'm done. Keep in mind when you're graphing reciprocal functions, there's extra steps. All right, what is the amp? Period is 2 pi or 2 pi over 2? Which is pi. Is there a vertical shift? Is there a horizontal shift? Is it pi? Okay, pi over 2, because you said this equal to 0. 2x equals pi. Because when you set that equal to 0, you add your pi, divide your 2, so it equals what? Pi over 2. So what is your start?
Pi over 2.
Pi over 2, and how do you find your end?
Your period and your start.
Good, start plus the period. So pi over 2 plus pi, what can I change pi to? What should I change pi to so it has a common denominator?
2 pi over 2.
Is 2 pi over 2 equivalent to pi? Yeah, why would I do that? Common denominator. All right, so what is the end? 3 pi over 2. One over 2, 2 over 2, 3 pi over 2. All right. Really quick. Okay, well, let's just finish this off. What's 3 plus 1? 4 cut in half. 2 pi over 2. I've been using decimals these last few days, so I'm going to use a fraction here. What's 2 plus 1? 3 can't be cut in half and get a whole number, so if you don't like the decimals, you do 3 pi over 2 times 1/2, which is 3 pi over 4. If you don't like this method, then you do 1 plus 2 is 3. 3 cut in half is 1.5. 1.5 pi over 2. Anybody have any preference this way or the decimal way?
I do
Decimals? It's totally your choice. All right, 2 plus 3 is 5 pi over 2, and that doesn't cut in half, 2 and 5, so 5 pi over 4 or 2.5 pi over 2. Your choice. All right, I am cleaning this up. What is the amp? 1. And, oh, did I already talk to you guys about subtracting? And on this particular problem? Okay, so what's your right minus the left, your end minus your start. What's 3 pi over 2? Take away pi over 2. And 2 pi over 2 is? Should it always end up being your period length? Yeah. Okay, so don't forget that. That is a tool you need. All right. Cosine, it's negative. So will I start at the max or the min? Minimum? Minimum, 0. Maximum, 0. Minimum. How many asymptotes do we have here? 2. Now, some of you will not be graphing. You do not have to graph your original sine and cosine and then erase if you can do without. Now, that's the way, like, how many of you can go here and know what it looks like? If you can, that's fine. On the inside, am I going to have a full shape or a half shape? Full. So it's opening up or down? Up, because I never go towards the x-axis. Here, there's no other asymptote. So will I have a full U shape or just half of a U shape? And is it going up or down? Going up towards the x-axis or down? And do I graph towards the green line or away from the green line? Towards. Okay, same thing here. Will I go up towards the x-axis or down away? Down away. Will I go towards the right or towards the left, towards the green line? Okay. All right.
Real quick, what you just did was figuring out whether or not the half graph is going towards or away from the asymptote. How do you figure that out?
It's never whether they do or not. They always go towards the asymptotes.
Okay.
Always.
How about
Up or down is they always go away from your x-axis or your fake axis. Like here's my fake axis here. It goes away. You will never go up and cross your fake axis, or in this case, the real axis. So if I went towards the green line but up, do you see that I'm crossing the x-axis? And I should not be doing that with these reciprocal functions. Justin, does that make sense?
Yeah.
Okay. So his question was, how do you know whether whether or not to go towards the green lines? You always go towards your asymptotes, always. Up or down, it's always away from the x-axis. If you don't like that method, then you lightly shade this, your cosine graph, and then you go opposite this line. This line's going up, so this one's going down. Same thing here and there. Any questions? How many of you feel like you can do without the lightly shading first or graphing? And that's fine. If it helps you, put the graph in there lightly with pencil and make sure you erase. Any questions? Yes. Yes, the graph on the inside you do. I mean, if I could see it lightly, I'm okay, but I shouldn't see a dark graph in there. And What's the biggest mistake kids make is they graph it and then forget to give me these pieces, and then they get it wrong. Questions?